Multi-point scaling is a feature that allows the user to set up and define up to 9 breakpoints to linearize a milliamp or voltage input signal. This is a standard feature with the West P6010 and P8010 indicators and can be very useful on non-linear process applications. I'm going to demonstrate this feature on a West P8010 indicator, and I will look at two applications. The requirement is to display volume of liquid in a tank. Firstly, a simple application on a rectangular tank, and then a more complex application on a horizontal cylindrical tank that has dished ends. The rectangular tank has a length of 3 meters, width of 1.5 meters, and height of 2 meters. The volume is length times width times the height. So 3 times 1.5 times 2 meters, 9 cubic meters. The end user wants the display to show litres. The conversion from cubic meters to litres is 1 cubic meter is 1000 litres. So the maximum display will be 9000 litres. The volume of liquid in the tank at any time is the fill height multiplied by the width multiplied by the length. So it is a linear system. It is a linear relationship between the fill height and the volume. The measurement of the fill height is being detected by either a pressure transmitter or an ultrasonic liquid level transmitter, and given an output of 4 to 20 milliamps. So the input to the indicator is 4 to 20 milliamps, and that equates to a range of 0 to 9000. So on the indicator, which simply go into the configuration mode, input 4 to 20 milliamps, range upper limit we put in 9000 using the up or down arrows, 9000. The lower limit is 0, and MPS, this is a multi-point scaling factor, is disabled. I'll just come out of that. Very simple to set up. We will now look at the application for the horizontal cylindrical tank with dished ends. This is basically the volume of a cylinder, but we also have to take the dished ends into account as well. So the capacity of a dished end tank is based on the length, the diameter, and the crown radius and knuckle radius of the dished ends. It has a length of 3 meters and a diameter of 2 meters, but because of the dished ends, it's a more complex application. It isn't a simple linear relationship of fill height and volume. The measurement of fill height is transmitted to the indicator as a 4 to 20 milliamp signal, so the input to the indicator is 4 to 20 milliamps. The maximum volume of the tank has been calculated by the site engineer to be 9760 litres. Also, measurements of fill height have been taken by site engineers at 10% intervals, and the volume calculated at those heights. This data is shown on the table. A graph has then been drawn showing the relationship between fill height and volume. You can see this is not a linear relationship. This is where the multi-point scaling, or MPS feature, is very useful. With multi-point scaling, we can enter up to 9 breakpoints to linearize the input signal. In this application on the horizontal cylindrical tank with dished ends, the maximum volume is 9,760. So we need to enter the range. So go into configuration. Input 4 to 20. The upper limit is 9,760. Okay, yes. The lower limit is 0. So that's the 4 milliamp equivalent, 0, and the 20 milliamp equivalent, 9,760. MPS. The default is to have it disabled. Now we want to enable it. Fine. We now have to enter those breakpoints in the setup menu. So come out of here and go into setup. Here we have first of all the scaling, SCA. Now measurements have been taken at 10% intervals, so let's put the first one in, which is going to be at 10%. And from the table we see that at 10% the volume is 507. So let's go down to 10%. Segment 1. And the volume was 507. And we'll keep doing this procedure for the other 8 breakpoints. $507. Now scale point 2, segment 2. Using the same procedure, I have already entered the scale points and displays for the next 7 readings. So that takes us up to 90%. So just go through this. Scale 2, 20%. 1358, 30%, 40%, and so on. So this is where I've got to. 80%, and the display is 8402. Now I've just got to enter the last scale point 9, which is 90%, and the display from the table is 9253. That is it. We've entered all the scale points from the table. The 100% value which is when we have a 20 milliamp input signal. We've already entered that as being the upper limit of the range of 9760. So we can come out of this, and we're back into normal operation mode. On this particular application, the customer asked if we could retransmit the display from the local indicator, from the P8010 indicator that we've just set up, to a remote display. And the question was also asked, do we also have to set up a multi-point scaling feature on the remote indicator? The answer is no. The linearization has already been done by the multi-point scaling feature on the local indicator, on the P8010. It's linearized that signal. So any signal that is retransmitted from the local indicator, from the P8010, is a linear output signal. And to demonstrate this, I've fitted a retransmit board into the local indicator with an output signal of 4 to 20 milliamps. And the 4 to 20 milliamps corresponds to the range 0 to 9760, the maximum volume of the tank. And on the remote indicator, again, the input signal, I've set it up for 4 to 20 milliamp input with a scale 0 to 9760 linear. And just to demonstrate this, I'll just change the input on the local indicator, and you'll see that the remote indicator follows that display.